Hi friends, this presentation is to give you a high level understanding about HANA, which is nothing but high performance analytical appliance. This is based on the learnings that I have got on HANA and is valid as on date. In this presentation, we will be discussing about information explosion that has actually led to the evolution of technologies like in-memory computing and maybe big data processing and other things. Then we will also have a look at the technology innovations that have actually gone into HANA, that how HANA has evolved at SAP. We will understand why HANA is called as a platform, then and who can use HANA. At the same time, how organizations can actually put HANA to use. And when finally we will discuss about the two most important cases how organizations use HANA, which is Sidecar and Enterprise HANA. Organizations today generate huge amount of data every day. They have got many applications that generate maybe GBs or maybe TBs of data every day. At the same time, we as individuals also generate huge amount of data on internet every day using using maybe Facebook, maybe Twitter, maybe by discussing on issues or maybe on topics on discussion forums. All this data put together, it's a huge amount of data that is generated, and it is said that if you write all this data on DVDs and stack those DVDs one above the another, the stack would go all the way to the moon and back. So that shows that we have huge amount of data that we have already generated, and we are still generating every day. Now this data has got wealth of information hidden inside it, which is not easily visible. You cannot see the trends easily. You cannot know about details of this data unless you process this data as per some algorithm or as per some logic and come out with results or with decisions. To do this, we need the new technology, or we need different technologies as compared to what we have been using traditionally. That is where technologies like in-memory computing comes into picture. These technologies allows us to analyze this data and come out with some sensible results. So this will be this will be helpful to maybe the top management of the organizations like CIOs and CFOs to find out trends in this data, for analysis of this data and to take better decisions. At the same time, such technologies like in-memory technology are also helpful to operational people and not just to the top management. If you see in today, the operational people face the problem of or face the issue of high wait time in generating reports maybe. So the line item level data is so huge that people have to wait for minutes or maybe for hours to generate the given report. In-memory technology also comes to the rescue of such people to generate reports at a much faster, high speed and reduce the wait time. So let's now understand what has gone into HANA, or what are the innovations that has gone into HANA that makes it capable to generate or to analyze data at such high speeds. Now, why is HANA called as appliance? So if you see that by definition it's called as high performance analytical appliance. HANA is called as appliance because it is a combination of hardware and software innovations both together. So if you buy a HANA box or HANA, it comes as a server that is a hardware box with a pre-installed and configured software in it, which is the HANA software. So if you can think logically, HANA, since it's an in-memory technology, your hardware is nothing but you might think a box having huge amount of RAM, but that's not all. It also has a few of other technology innovations inside it that makes it unique from other hardware. At the same time, the software that has been installed on this hardware is configured or made in such a way that it actually makes optimum use of this hardware. Hence, comes as an appliance, which is a hardware plus software. Now, let's understand quickly that what are the innovations for hardware and software both. On the hardware front, we have in HANA something called as multi-core architecture. With this, the HANA server has got multiple CPUs and each CPU having multiple cores. So that gives the HANA box capability to process data in parallel. So if you, for example, if you give an instruction or if you give a task to a HANA, if you talk in layman terms, it has the capability to divide the task into multiple smaller tasks, feed it to each of the processor or each of the cores, and get the results back at a much faster speed. That is where the speed comes in from. That is one of the points where the speed comes in from. At the same time, it has got a 64-bit address space, which means each of the processor of the HANA box can address 2 terabytes of memory. This gives the HANA server capability to process or to store huge amount of data in the RAM and make it readable as well by the HANA server. So this gives the HANA box capability to store to have huge amount of RAM as well. And on the software front, the major innovation that has gone into HANA or come into HANA is column-based data storage. So column data storage has got many benefits, which are like compression, partitioning, no aggregate tables, insert only on delta. So all these 4 below are nothing but it's all advantages or benefits of the column-based data storage. However, in addition to that, it also has row-based data storage. So if your requirement demands that you store data in a row, you have the capability to store it either in a row or you can store it in column depending on the requirement. Now, just to understand quickly that which is better. For example, if you have a table that you always read the complete row at a time. So if the table has say 50 fields, then you always read all the 50 fields at a time. In that case, it's better to use a row-based data storage. At the same time, if you have a requirement wherein you want to read only say 3 to 4 columns out of the 50 fields at a time, then you should use column-based data storage. Now, if you think logically, 95 to 98% of the times, all your requirements, all your tables will always be read at a few columns or a part of the total columns at a time. So, which makes most of the tables to be better stored in a column-based storage. When you store data in a column-based storage, it helps it enables you to achieve much higher compression. So the data that you store in a web-based storage will, if it takes say X amount of space, it will be X minus delta amount of space. So the compression rate and the compression rates are quite high. At the same time, in HANA, you don't need to aggregate tables. For example, if you know about business warehousing as a system, you will also know that in BW you always have to keep on data at aggregated level. It's a thumb rule that you should not generate item level data, stored item level data in BW, or you should not display item data level data from BW. It is more to be used for analytical per se or for analytical purposes. So, and you always tend to aggregate data at month level. For example, for sales, you tend to aggregate data at month level and not at billing document and day level. You always store it at month level and then display it to the user so that the user does not have to wait much for aggregating data and displaying it to the end user. In HANA, there are no such restrictions. You simply store the data at your item level, and HANA server is capable enough or fast enough to aggregate data on the fly and give performance that is much better than BW. At the same time, it also inserts only on delta. That means your writes are also faster, or your writes are better. Why? It inserts the data into the database only if there is a change. So from point A to point B, if you have done say 15 to 20 instructions, it will send the data to the transfer only that data that is actually changed in that duration. So that saves the time. So that again helps in increasing the speed. So all these technology innovations put together gives the HANA server capability to first of all store massive amount of data and process them in real time. Now it's important, one more important point to understand is we say that HANA allows you to do real-time analytics or real-time analysis. Why? Because it has there are some other technologies like SLT which are available that allow you to bring data from some other systems in real time, store it to HANA, based on which you can analyze the data. So it helps you to generate the real-time analytics. Let's understand another important innovation that has gone into it. So this is a part of what we already discussed, but since it's more important, let's understand this a bit in detail. So this is the traditional approach, wherein we have on the bottom part we have the hard disk, which stores the complete data plus whatever logs we have. Then we have the RAM, which stores temporary data, and above that we have the CPU. So in case the user asks us to show some data from say module or from materials management module, it will simply pick the data from those tables into put into RAM temporary, and then process it in the processor and display the user result to the user. So if you see, the bottleneck here is transferring data from the hard disk to the RAM. This takes the highest amount of time. Once it is in RAM, the transfer between RAM to CPU cache and then to the user is much faster. There's no issue in that. So the bottleneck is transfer from hard disk to RAM, and that is exactly what we have eliminated in HANA. So if you see, in HANA, your RAM is big enough to accommodate all the data that you want to analyze. So if you think in layman terms, you can simply think that your complete hard disk data is available in your RAM. But still we need the hard disk. Why? In order to back up the data. Right? So in case if there is a power failure, if there is a failure, we have the data backed up in the hard disk so that we can recover the RAM. At the same time, on the top level, if you see, there are multiple CPUs and cache. So you have multiple L1 and L2 cache, and you have also multiple CPUs. So as we discussed in the last slide, it gives you capability to process parallelly. Another important thing to note here is the solid state disk, SSD. Now this SSD is, if you think in layman terms again, it's like a pen drive. So it has the capability to store data, and it has also the capability to retain that data in case of a power failure. So if you think logically, if you are executing some transactions, and if you're doing some work on your HANA system, obviously it stores most of the data and in the RAM, but the current transactions that are in process or being executed or recently committed are available in SSD as well, are available in SSD. So in case of a power failure, you obviously will lose your RAM, but when you come back online, you can recover the data of your RAM from your HDD, from a hard disk, which is always backed up, and you can recover your online transactions or maybe a last few minutes of work using the SSD. So that gives HANA the capability to ensure that the database is ACID compliant, as well as you don't lose any data. It gives you the capability to point-in-time recovery. Now let's understand how HANA has evolved. So it's important to understand that HANA is not something completely new that has come up at SAP. So in-memory technology has been around at SAP for the last few years. I'm sure you might be knowing about live cache on APO server, which is advanced planner optimizer server. So all your applications like demand planning, supply network planning, and PPDS, they run on the live cache. Now live cache is nothing but you have your transaction as well as your master data loaded in your live cache, which is nothing but your RAM. And you have your complex business logic that run on that data. So this obviously requires huge amount of processing power and speed, so that you can churn this data using that algorithm to predict what will happen in future and generate the plan. So that is where SAP had already used the in-memory computing capability. On the reporting front, we have something called as BW accelerators, wherein you copy a part of your data from your server into the BW accelerator server, which is again a separate hardware, and you generate report using this BW accelerator. So what happens is the BW accelerator hardware indexes the data by itself. So when you query the data that is stored in the BW accelerator, it will take much lesser time to retrieve as compared to if the same data is stored in a normal BW server. So this again an example of in-memory computing that SAP already had. Now, what is the major difference between these two technologies and HANA then? Now, HANA is complete database in memory. However, in the two technologies that we just discussed, it's a part of the data from that is only in memory and not the complete data. And the business logic and other things also do not run completely in memory. However, in HANA, your business logic, your data, everything remains in memory, so that it is much faster. So based on the learnings that SAP had using the API live cache, using BW accelerator, and using the technology innovations that we have already discussed, HANA has evolved. Now, it's important to understand that HANA is a platform. Let's understand why and what is a platform. Now, first of all, we already have discussed that HANA stores data. So it's a database, a known fact. You can use HANA as a database. So you can store your data into HANA and retrieve it using some application or something. So you are using the database capability of HANA. So you are using that data that is residing in memory and retrieving it using your applications. So it's a database. In addition to that, HANA also has something called as a calculation engine. Now, what is a calculation engine? In a normal database, if you store data, if you want to retrieve data of say last sales of last 1 year, so what would happen in normal database? For example, if you consider that you are executing a report in BW that shows the data of last 1 year, so a traditional database would retrieve the last 1 year sales at the line item document level, and you would aggregate that in your BW system and then generate the end report to the end user. So the end user might see a single row that the sales in the last 1 year is say 1 crore rupees. But this would demand that your traditional database pass the complete item level data to a BW where it's aggregated and shown to the user. However, in case of HANA, this aggregation is done by the database itself. So you have to explicitly use the calculation engine for that, so that when you query the database saying that I want the last 1 year sales figure, the HANA database will simply aggregate it to itself using the calculation engine and return only a single row to the BW server, giving the sales as a single row sales or single digit sales to the user. So this speeds up the transaction, the speed at which the data is retrieved. At the same time, it also has something called an extended application server or access engine. To remember it, or it also called as an extra small engine. Now this is a very important layer, since this gives the HANA server capability to even process business logic. So if you want to create a new application for your organization or for your own use, you can actually create it in the HANA server. So just like you create applications using C language, and you create application C language and you sell it in the market, you can also create your own applications in HANA server and then sell it to others who can use their own HANA server. So this is why most important reason why it's called as a platform. It also has the capability to process business logic on itself. At the same time, it also has something called as a web server engine, so that it allows the developer to generate an interface for the business logic that maybe he has just written using the extra small server, which is extended application server. So the interface will be HTML5 based, so that this interface is capable to be or any browser that is HTML5 capable can consume this interface, and this interface will run obviously on all mobile devices, tablets, on your laptop, and everywhere. So these are the most important reasons why HANA is called as a platform. With these four put together, it allows a developer to create something complete application on the HANA box. So he can store the data in the database, He can do computation using the calculation engine. He can write in the complete business logic using extra small engine, and he can even create the interface for the end user using the web server engine. So, for example, if a bank might want to create its own application, complete application on the HANA box, so it's possible. So that is why HANA is not just a database that companies might use to install their applications on. It's a platform that any developer community or any organizations can use to develop their own complete application. Now, who can use HANA? With having understood that what a platform is, I'm sure we already have guessed that startups, developers can use HANA first of all. So it's not necessary that you need to be a company or a big organization to use HANA. Any small company that has just started or is already in the selling applications can go for HANA to use its in-memory capability, create its applications over HANA, and then sell it in the market. At the same time, organizations can use HANA to host their own applications. Now, this does not mean that organizations are limited to organizations that are already customers of SAP or run SAP products. Maybe even a non-SAP company, for example, a banking company might want to go for HANA and install its application over HANA and run it. So this gives it the advantage of in-memory computing, so much better performance. At the same time, organizations that are already SAP's customers and want to run their products like SAP ERP, SCM, or other products on HANA can also do that. So both organizations, organizations who are already SAP's customers can also use HANA. Now, how can such customers use HANA? For that, there are two major approaches. One is sidecar HANA approach, and another is enterprise HANA. So there are other ways as well. So these are the two most important approaches in which existing SAP customers can use HANA. Let's understand how. In sidecar HANA, what we have right now shown is the existing architecture of HANA. For example, the current slide shows the existing landscape of the customer, for example. So you have your SAP ECC application which is running on an Oracle or a MaxDB database. The interface that I have shown here is SAP GUI, which it's obviously SAP ECC can be accessed through SAP GUI based interface, or maybe using SAP EP for your web info applications, or using HTML5 apps. So we have something called as a NetWeaver gateway that allows any organization to develop HTML5 based apps on your consuming the data and other services of your SAP ECC server. So this is the current capability of an organization, say, and let's understand how it can benefit from the capability of HANA. So in such cases, what happens is the organization goes for SAP HANA server as a sidecar. So if you see, the SAP HANA is parallelly running with your current infrastructure, and it gets real-time data via SAP Landscape Transformation or SLT. Now we pull only the most important or the bottleneck tables into HANA. So for example, if normally organizations have tables like MSEG, then LIKP, LIPS as the bottleneck tables, and VBFA. So these tables are huge tables having item level data, and are the most important bottlenecks why transactions or why applications take time to execute. So what we do is in sidecar HANA, we pull those tables into HANA, which are bottlenecks in SAP ECC, using SLT, and SLT guarantees that the data is real time. So as soon as it is created in SAP ECC or in the existing database, it is pushed into SAP HANA. Now this lag could be the time lag required could be a few milliseconds or a few seconds, but ideally it is real time. So once we have this data available in HANA, we have two databases, right? your primary database, which is nothing but maybe Oracle or MaxDB, and a secondary database which has the most important or bottleneck tables in itself, which is SAP HANA. Now let's see how this secondary database can be used. Now this secondary database, first of all, can be used as only read access. So if you see this arrow which is shown here, whenever somebody executes a given transaction, say MiGo, which also reads MSEC table, and MSEC table is already available in your secondary database, which is HANA. So your MiGo transaction reads many tables, right? In addition to MSEC table. So the MSEC table, which is the bottleneck in SAP ECC, is read from your secondary database. Rest all tables are read from your existing primary database. So this speeds up the MiGo transaction. So this is one very important use case how Sidecar HANA approach is used. So your existing infrastructure speeds up without any changes required. So there are a few activities that are required on a HANA server, but it enables you to speed up your existing ECC standard transactions as well as your Z programs using secondary database. So all the heavy tables that your standard transactions or your Z programs read can be copied into your secondary database, and when it actually executes, it will be redirected to SAP HANA for those specific tables that are heavy. Rest all tables will run from your primary database. This also stands true for your WebInfo based applications. So whenever they are running, they can fetch data from a few of the data from HANA and rest from Oracle, and at the same time from your HTML5 based apps. At the same time, you also have the capability to create HTML5 based apps, as we just saw that why HANA is a platform. You can also create it also has a web server engine which allows it to generate HTML5 based apps directly in HANA. So if you have say 15 or 20 or 80 tables in HANA, and based on which you want to generate a report, you can directly create a report in HANA and generate it out of HANA. Now why would somebody do that and not create the table report in ECC? This might be required because everything runs in memory here. The business logic of the report, the data is in memory, and the interface logic, which is your HTML5 based app based interface. Everything runs in memory. So the speed is much faster. At the same time, you also have a tool called the SAP Lumira, which is a self-service analytical tool, which you can use for analyzing the data. So you have something called as HANA Modeler that allows you to do modeling in HANA, which is nothing but clubbing the different tables that we have in HANA and generating a view that can be actually consumed by the end user using Lumira. At the same time, your existing SAP BO infrastructure, if you already have SAP Business Objects, you can also use this SAP Business Objects infrastructure to connect to HANA directly and consume the data that it has. So if we sum it up, there are three ways in which we can use HANA, Sidecar HANA. One is by accelerating your standard transactions. So as we took the example of MiGo, we can speed up transactions like, for example, let's take MB51, which reads line item level data. We can speed up transactions, such transactions. We can even accelerate custom developments, which is nothing but your Z programs that you might have developed. So the interface remains same, either SAP GUI or SAP EP. They will read data from few of the tables from HANA, or reporting via HANA. So this talks about the other three scenarios that we discussed. So you can create either HTML5 based apps or use Lumira or BO to do reporting via HANA. Now let's understand what Enterprise HANA is, having understood Sidecar HANA. In Enterprise HANA, we simply replace your traditional database with your HANA database. So if you remember in your last example, which is a Sidecar HANA, HANA was a database that was running in parallel to your existing infrastructure, which was running on Oracle or MaxDB, and you were using only selective tables were copied to HANA and read from HANA. However, in Enterprise HANA, we simply replaced your complete existing database with HANA database. So this again is non-disruptive in the sense all your current applications that are shown on the top, which is SAP GUI based or SAP EP based or your HTML5 based apps, run as it is. You don't need to change anything in your existing applications. The only thing is everything runs in memory. So since the database has changed and it is running in memory, and you have installed your SAP ECC on a database that is already running in memory, everything runs in memory, and you all obviously get a huge performance benefit. At the same time, as we discussed in the last slide, you still have the capability to use HANA to generate applications. So as we said, HANA is a platform. You still can use HANA in this case to generate HTML5 based apps on HANA using the Access engine. Then you can consume your data in HANA using Lumira and using SAP BO as well. So this obviously simplifies the infrastructure. If you see, the landscape is also much simpler. You're using a single database for your transaction execution. So your business users will execute users will execute data using your SAP GUI, and the same data is stored in HANA database in tables. The same tables are directly used for your reporting, which is via HTML5 based apps or Lumira or SAP BO. So this is what is called a real-time reporting analytics. So there is no time lag between one day delay as we have in BW. Whatever data is written by the user in your HANA database will be available for reporting at the same instance. So this allows you to do real-time analytics, and also speeds up your transaction reading and writing, since you are running everything in memory. So this completes the high-level overview of SAP HANA. If you have any queries or you want to discuss on any points, the web is open. You have got a lot of information available on HANA on portals like open.sap.com for developers, and help.sap.com. You have a lot of video tutorials available on that. Or at the same time, if there are some specific points to discuss, please feel free to send me a mail on mailanup@gmail.com so that we can start a discussion chain on that. Thanks for your time.